Welcome back. Okay, right now we're going to talk about the symmetric feature or characteristic of the unit circle. Now, like I've said before, if you put a cross inside, right in the middle of a circle and extend the cross indefinitely, that cross would divide the circle into 4 equal parts, right? Given that it was placed in the center at the beginning. And that's what gives us the 4 quadrants that we talked about in the last video, right? The A quadrant, the first quadrant, which is the A quadrant, where everything is positive in there, sine, cosine, and tan. And the second quadrant, it will be the S quadrant, where only sine theta is positive in there. And third quadrant would be the T quadrant, where only tan is positive in there. And the last quadrant, or the fourth quadrant, which would be the C quadrant, where the only cosine values in there is positive. So why is symmetric, the feature of symmetrical in unit circle so important? It is because of we can identify the complementary angle or the supplementary angle. The symmetric feature of the unit circle allow us to find out these two, the complementary angle and the supplementary angle. All right, now the by complementary, I know that I means that in a unit in a right angle triangle, in a right angle, right? So if there's a theta 1 here and there's a theta 2 here, we know that theta 1 plus theta 2 must equal to 90 degrees, right? Because because inside a right angle, there's only 90 degrees. Okay, that is the supplementary angle. So theta 1 is that is the complementary angle. So theta 1 is the complementary angle of theta 2, and theta 2 is the complementary angle of theta 1. All right. Now for the supplementary angle, we happens in a straight line, right? And we've got a line like that. So the theta here, let's call it theta 3, and the theta here, let's call it theta 4. So these two are supplementary angle to each other, because theta 3 plus theta 4 must equal to 180 degrees, because that's the amount of degrees, that's how many degrees in a straight line, 180, right? So we can say, there's something wrong there, should be pi with theta 4. So we can say theta 3 is the supplementary angle of theta 4, or theta 4 is the supplementary angle of theta 3. All right. So using that, right, if we are looking for a particular angle, or if we're given a particular angle in here, let's say this is 60 degree, right? And to find out the cosine, so the sine, all we have to do is just go sine 60, right? And it's a positive value, right? And if you want to find out the x-axis, all we have to do is just cosine 60. Right? The other bit is just sine 60. Right? And tan is just tan 60, right? Because everything in here is positive. And in terms of 60, we can get an exact value, right? Remember our triangle, our special triangle, right? So it's 1, root 3, 2, 60, and 30. So we know that sine 60 is opposite over hypotenuse, which is root 3 over 2. Root 3 over 2. And cosine is 1 over 2. And the tan will be root 3. Right. That's easy, all right? We've got an exact value for an angle. Great. But what happened if this particular angle that we're looking for is beyond the first quadrant, all right? Because we never get, we don't always have a nice number like this within the first quadrant, because we know everything inside the first quadrant is positive. So what happens if we move this arrow? Oh, well, let's just delete it. What happens if we draw a new arrow? This is a good point here. If we draw a new arrow, and do it that way, yeah, and now we are asking for this particular angle. I want to know this particular angle. Oh, sorry, we're given a number for this particular angle. Let's say 130. Should we? Would it work? No, 112, 120. 120. Now, if this theta is 120, right? We don't have an exact value. We don't have a triangle that has 120 degree in one of the corner. So our exact value, we can't find an exact value for this particular angle, right? But what we can do is we can look at the supplementary angle of this of 120. Now we know on a straight line, the angle have to add up to be 180. All right. So if we got one angle of 120, the supplementary angles of this particular angle would be 60. So we know this particular angle would be 60 degree, right? And we have exact value for 60 degrees, right? We just did that. So the next thing what we have to do is we just have to be careful. What are we actually looking for? So if you go sine 120, right, and that is looking for the y value, right? Remember that is looking for the y value, and we get a positive because in the second quadrant, where 120 degrees is in the second quadrant, we get a positive y value, right? Because it is here, positive y value. So therefore, when we do the supplementary angle, supplementary angle sine 60, yeah, we are still looking for the y value of this point, right? So I guess now the blue line represents the x value. All right. So in sine 12, sine 120 and sine 60 actually both share the same y value. Yeah, they're both positive. So we can say that sine 60 is actually equal to sine 120, simply because they share the same y value. All right, but on the other hand, you can't say cos 60 is equal to cos 120, right? Because in cos 60, which is somewhere over here, we will have a which was the line before. We will have a x value of half. But on the other side, even though it is symmetric, right? So in here, this would be negative half, because it's on the other side of the x-axis, right? It's on the negative side. So instead of cos 60 is equal to cosine 60 is equal to cosine 120, cosine 60 is actually equal to, how should we do it? So cosine 60 is actually equal to negative cos 120. Simply because the x value in here, we know what the x value is. The x value is the same as the x value that is cosine 60, but it's just negative, right? It's the same value, but it's just the sign has changed from a positive to a negative. simply because we're in the second quadrant now, where only sine theta is positive, right? And therefore, the last one we're going to talk about is the tan quadrant, so the tan theta. So tan 60, right? Now we know tan 60 is we know tan 60 was root 3 before. It was a positive root 3, but now is tan 60 actually equal to tan 120? Is it actually equal to? Let's have a look. Remember, tan is sine theta over cosine theta. Now, the sine theta is okay. The sine theta, the value did not change, right? The sine theta value did not change. It's still root 3 over 2, just like here, right? It's still root 3 over 2, just like here. So this particular point. But then the cosine value has changed. Instead of half, it has changed to negative half. So the tan, remember, tan is equal to sine over cosine. So it will be, so instead of over 1, just like it's at 60, in this time it will be over negative 1, or because there's a negative sign in there. So for the same thing, for the tan 60 is actually equal to negative tan 120. Simply because both tan and cosine is in the second quadrant, which is the S quadrant, and only the sign will be positive there, and because only the Y value will be positive. Yeah, the X value is negative. All right, so next, another example. Another line. Let's do another line. So let's go somewhere across like that. All right, let's do something like this. Okay, somewhere here. All right. Now, according to the angle rule, all right, this particular angle is the same as this particular angle. Right? So we know that, I have to worry about this a bit. Look this out a bit. And then I use the la. Hopefully I can connect them. Okay. So we know that this angle here is actually equal to that angle according to the rules. So this would be 60 as well. Right? 60 degree. So, but the actual angle, if we start from the 3 o'clock position, will be 90, 180, 270, plus is the complementary angle here, which is 30. Yeah, that will be 30 here. Right. So that would actually be so this is actually the whole thing. Woohoo! Here is actually 300 degree. Yeah, 270 plus 30. Right? Now 300 degree is we don't have a value for 300 degree. We don't have an exact value for 300 degree. But mind you, the complementary angle of that would be 60. Right? Would be the 60 angle here. So we can actually use this 60 because we have exact value for sine, cosine, and tan of 60s. All right. So let's look at that. Let's look at sine first. In sine, in here, because this quadrant is the C quadrant, right? The fourth quadrant, the C quadrant. So all the X value is positive, but all the Y values are negative. All right. So sine 300. Oh, sorry. Let's just go sine 60 here. So sine 60, is it still equal to sine 300? No, because sine 60, the Y value is on the top. Is at here. It's the first quadrant. But in this one, if you do it symmetrically, it should be the same value, same Y value, but instead of positive, this will be a negative. So sine 60 theta, sine 60 degrees is actually equal to negative sine 30 degrees. Simply because it is on the fourth quadrant, or simply because it's in the fourth quadrant, the C quadrant, and also all the Y value here is negative. All right, the number will not change. Remember, guys, the number will not change. Just the sign, positive and negative. All right, and cosine 60 is it equal to cosine 300? Well, let's look at the x value of this particular point. That's the x value. All right, so I was actually meaning this. The red thing was actually this before, so that was the sign. So the x value is actually positive, all right, because it's on the left hand side of the Cartesian plane here. So therefore, cosine 60 is the same as cosine 300, right? Because the whole thing is symmetric, and they both come back here at this particular point. All right, and the last bit is the tan. Now, hopefully by now you would have realized a particular pattern. All right, tan 60 we know is a positive, simply because both sine 60 and cosine 60 is positive. But in the fourth quadrant, only one of them is positive. So tan 60 will not be the same as tan 300, but instead it will be the negative of tan 300. Simply because right now the sign is a negative values. And sine and negative value over positive value still give you a negative value, right? Simply because of that. So in conclusion, the symmetric feature of the unit circle or the complementary an angle and the supplementary angle is just allow us to figure out some of the complementary angle and supplementary angle and use exact value to represent sine theta or cosine theta or tan theta. It's just that. As long as you guys, don't worry about it. It might look complicated at the beginning, but just keep this one straight fact in your mind. Sine theta is the y value, cosine theta is the x value, and tan theta is the y value over the x value, right? If your y value is positive, so within the first half of the circle, all the y value is positive. So therefore, in the first two quadrants, the sign is positive in there, simply because in the first two quadrants it's all on the top side of the Cartesian plane. All right. In the second two quadrants, if you look at it vertically on the right half of the circle, right, on the right half of the circle, all the x's are positive. All the x values are positive because of this x-axis. It's all on this x-axis, so it's all positive. So therefore, first quadrant and fourth quadrant cosine will be positive. All right. The last one is just simply because tan is equal to sine over cosine. All right. If one of them is negative, cosine will become negative. But if both of them is negative, cosine will become positive. Therefore, diagonally in the circle, diagonally, so first quadrant and the third quadrant, tan is positive, right? Because in the first quadrant, both sine and cosine is positive. So positive over positive give you positive. In the third quadrant, both sine and cosine is negative. So negative over negative give you positive. All right. And that's pretty much about it. All right. So, this is really 5 episodes on this unit circle bit topic. Look, the unit circle topic is important for year 11 and year 12 maths B. So I don't mind, making more than one video or more than 2 videos about to talk about it, to go through it. As long as it helps you guys, I don't really mind. And hopefully you will find it fun. Unit circle at the beginning, when I first looked at it, it was hard, because I simply don't see the connection between the symmetric line or symmetric angle inside the unit circle. But once you see it, once you realize it, once you find out the pattern and the relationship between them, they are easy. All right, you guys can do it. I believe in you. All right, and this will be the last video, and this will conclude the unit circle. All right, the next one we'll be looking at will probably be periodic function. You know, your sinusoidal function, your sine graph, and your cosine graph. Which to your surprise, you know, which I wouldn't be surprised, is a bit related to this, right? Because we are talking about sine and cosine in here. All right. Thank God we don't get to draw the tan graph. All right. Until next time. See ya.